commence et après un peu prépare la marine et ensuite on écoute les éléments. Très bien.
Elle commence. On attaque sur elle.
Vous affichez Marion pour commencer.
C'est parti.
So we can start? Yes. Good morning, everyone. Bonjour à tous. Welcome to this day 2 of the InfoBeam Open. I will share this morning with Marion Schenkwein the session named BIM on GIS General Practices. We will have 4 presentations this morning until 11. And I will share the session with Marion. Marion, good morning.
Good morning.
Good morning, Marion. It is so sad you cannot be here in Lyon. You welcomed us so kindly 2 years ago in Tampere. It's so sad you cannot be there. But you will be our digital convener this morning. And
Yes.
you will follow the question in the Brella site. Can you explain, please, how to connect to Brella and how to ask questions on Brella? And sorry.
Yes, we'll
We
do
have
that.
prepared the survey also.
Okay, so if you go to Brella and choose your stream here at the top of the screen, then you should have a view like this. And if you have any questions, please type them here in the chat. So I see there is a question from Matthias Müller already. He's asking, did it start already? So I'll just answer him. And yeah, so when you have questions regarding the presentations and so on, please write them down here so we can ask them, the presenters, later on. Okay?
And can you explain us the survey also, please?
Actually, the survey. The survey, is it going to be in this chat window as well? I have to admit, I'm not so sure about that.
You received the URL this morning from Gersand, and if you can put the URL in the Brella chat,
Yes,
so that
yes,
you
okay,
can
yeah.
answer the question we prepared for some presentation for this morning.
Yes, so I will paste the link then to the chat as well.
Can you introduce you a little bit, Marion, and I will introduce myself because I forgot to make it.
Yeah, sure. So Vincent already told my name, Marion Schenkwein. I'm InfoBIM expert from the Finnish Transport Infrastructure Agency. I've been working with BIM in infrastructure, well, I think something like 15 years or more, 17 years maybe. And yeah, I have been, I began my career as a designer actually in roads and streets and railways, and yeah, have then been moving through different positions until I'm now at the Finnish Transport Infrastructure Agency.
Thank
And
you.
I've been working with national and international standardization in BIM also for quite a while already.
Thank you, Marion. And myself, my name is Vincent Keller. I'm from Aegis. I'm the head of the digital engineering department for the rail domain in Aegis, and I'm also the co-leader of the French national research project MIND. So we can start with the first presentation, which named Visualizing Subsurface Object Integrating Confidence Levels for Geospatial Positioning and Geometry. And I give the mic to Mr. Kamel Adwan. I let you present yourself. Thank you.
Merci beaucoup. My name is Kamel Adwan. I'm going to present this presentation about visualizing subsurface objects integrating confidence levels for geospatial positioning and geometry. This work is supported by the HESSO, which is the University of Applied Sciences and Arts of Western Switzerland in Geneva. So the structure we will follow in this presentation is the following one. First of all, an introduction stating the overall context of digitizing subsurface objects, the main realizing objectives of the subsurface project, followed by involved and the steps we went through. And afterwards, I will present a series in this presentation. We also qualified spatial, which is incorporated in the validation part. And afterwards, we will conclude prior questions and answers. Urban subsurface areas are identified as valuable spaces for construction, and this is especially true when it comes to be done in accordance with its main function. However, data is required, so to but are which means that there is a possibility to get this data we are looking for. Here is need to think and all official GIS databases like data sets for subsurface objects. However, in a different way, be fully projected in 3D. Young subsurface and especially useful for use as clash detections or density estimations. The overall objective of the project is to obtain a complete description of subsurface objects, including placement and geometry for the management of underground volumes. In order to fully place an object in 3 dimensions, we need both of a placement plus a geometry. To control our data flow, we went through, first of all, the development of a data structure for subsurface objects, which is called the minimal data model, that specifies all our geometric primitive requirements. We then went through the integration of the information present in the SITG Geneva database to fit our minimal model requirement for the data we already. If some of the data we're looking for is not available, to identify it first and then additive hypothesis. Also, we had to determine the confidence level for the represented data, since uncertainty gather in our data flow. And finally, we went through a qualification of spatial information for underground volumes. Complete massive but complete databases, determination objects, and finally the qualification of spatial information of underground volumes. To control our data flow from our GIS database towards our RDF triples, we went throughout a series of 4 steps, the first one being the modeling step to check our abstract model type classes and select them. Second one being completion step to complete all our model requirements. Then the bounding step, which is the third one, to get the uncertainty models and probability density functions per geometric parameters. 4 steps is the integration of all these informations towards an RDF triple store before being projected on a 3D that we can fully visualize objects underground. A set of simplifications of geometry involved in the models to represent, for instance, building modeled by polylines extruded. To model foundations, we used cross sections of rectangles along a line. Cylinders are also used in our model, or tube and pipelines as geometric primitives. Let's have a look to other sets of simplification of geometries. Pipelines with rectangle sections crossed again. And since there is an uncertainty along the depth which is characterized by the alpha angle. Of cubes to characterize truncated cones, again with this alpha angle for the uncertainty along the depth, and a set of 2 cylinders again. The SITG database we used had first to be completed before our geometric parameters can be fully used. However, we had to face 2 to cure before seeing our objects in 3 dimensions. We will see examples on the 2 next slides. The first aspect we had to correct is quite rare and concerns the dimension of some utility lines. And the second one is more often concerns the depth of the subsurface elements, which is, for instance, the Z coordinate, a confidence level associated to the precision forecast, according to Geneva experts interviews, is developed. Let's have a look to our first example. Object underground, we need both of a placement plus a geometry. In that case, we want to place pipeline underground. The placement is complete. The geometric primitive is incomplete since the diameter was originally missing. We had to complete it by adding a hypothesis about the diameter, which is characterized by this green arrow. So that now our object is conceptually complete and we can project it 3D. Second example, we have a geometric primitive which is a pipeline which is complete, but the placement is not pipeline. The XY is not missing, so we had to use law, which is a statistical law called PERT law, which is a beta law characterized by the set of 3 coefficients, coefficient A, B, and C, 5 centimeters. This law is calibrated with empirical data from a different location with a similar data sets, so that the depth in the different data sets is not missing. In the SITG database, the positioning and the depth are subject to uncertainties. This uncertainty is captured onto a dual form called the secondary geometry objects. In the case of a natural tree root, we have both for the primary object and a secondary object, a cylinder. In the case of a pipeline, for the primary object, we have a tube. For the secondary object, of a rectangle. Confidence size, with a higher degree of confidence, then the bounding volume increases. However, this representation is purely conceptual. So now we'll have a look about how it can be implemented. On the left-hand side of the slide, there is a water pipeline network, which is conceptual, blue for the primary geometry, with a set of 2 degrees of confidence for our 2 secondary objects. This concept is implemented on the right-hand side in Cornavin area, still for the water pipeline network. The strategy of our subsurface global workflow for our data is to converge all the information towards an RDF triple store, which is inclusive, first of all, of the development of an ontology RDF expressed in O. This gathers information about the minimal model. We then need to get all our information from database with a set of additions. They are formatted according to the generic rule representation model. Also, some artificial intelligence use surface object positioning and geometry. When all this information had converged towards the RDF triple store, we then have the possibility to project this information in 3D, to visualize and apply compliance rules. The amount of information available in the SIGG database is exhaustive. Here we have as the type of plantation, as group of or life experience, like information is not directly linked to the geometry, so we did not select all the information present in the SIGG database. Flow from the GIS layer towards the RDF triple store database needs information about how to characterize a cylinder in the case of the or a tube in the case of a natural gas pipeline, or truncated cones to model the secondary object for piezometers. Let's now have a look to the results. We propose a set of 2 subsurface areas to expose our results. The first location involved is Cornavin area. This area is interesting since, first of all, this is central in Geneva, and there are lots of subsurface objects present in this area. This is also where we can find a train station. The area surface is 0.32 square kilometers. And the second involved is PAV. PAV is intense in subsurface object densities. The area is quite similar to Cornavin, and also in the center of. Propose now a live demo to expose our results. In this map, you can recognize the center of Geneva with the Lac Léman on the right-hand side. the straight lines represent the utility lines in the sign.
Hello, good morning.
Hi, Evandro. All good?
Good,
The
good.
ground
What about
utility. In addition, we can identify volume around which incorporates the precision parameter. We expose the high-level density presence in the undergrounds of Geneva. In this, we also have the possibility to get the details about the layers involved in the 3D. They are displayed connected networks. And finally, an additional view to consider building above the surface. The demonstrator comes with a series of computed analytical functions to assess subsurface occupation, that we are going to see right now. So in this view, the darker blue undergrounds are. Also, this view can be superimposed by the tribute layer to understand the variation of density levels. This analytical function is based from volume assessment of underground objects in 3D, as seen on the front-end interface. Please contact Mr. Stefan Kuderk, which is CEO of Topomat, to get your login and passwords or more information about the interface and the latest updates. We also qualify the information. In that case, we have to count some primitive parameters. Counting ratio. Fine version, which is considered per class object. One computed which is refined complete. Offering more of incompleteness than others. We also use the density metric use of underground space developed by Bobilev in Berlin. It is about 130. Our results are similar for PAV and Carnavin, 130 and 50. It's a bit higher, but the magnitude is similar. As a conclusion, that witness accuracy, levels of detail and format, time-consuming data curation operations are needed before compiled sets can be used for analysis. Data from BIM systems can be the representation of subsurface objects. And if the data is imprecise and incomplete, it can be used to provide a coherent representation of subsurface volumes. And finally, the developed representation of subsurface objects allow the creation of use cases like detection of potential and planned underground facilities. Thanks to the Swiss Innovation Agency to support this project, made by 2 academic partners, University of Sciences and Arts of Western Switzerland, the University of Geneva, and Topomat, the industrial partner. We also have a series of implementation partners in the state of Geneva. This project allowed the creation of 4 research outcomes in journals and proceedings, 2 in international workshop on intelligent computing and engineering 2020 Munich, 2021 Berlin, and 2 journal papers, International Archives of Photogrammetry, Remote Sensing by Claudine Mitchell. In the journal PI, Switzerland Publishing House. This is my email for contacts. Now the floor is open to questions and answers.
Thank you very much, Mr. Adwan. It's impressive that you have demonstrated that there is a real added value to manage and to generate some information in GIS in 3D so that we can manage the subsurface of city. Marion, do you have any questions on BRELA to ask to Mr. Adwan?
No questions in BRELA yet anyways.
So do you have a question in the room? Is there a question in the room? Yes? Can you present yourself, please?
Hello, I'm Lucas Daval from Bureau SGI. We are engineering bureau anyway. What kind of data did you receive from water, electricity and gas providers? Is it already 3D? Do they have already 3D data in Switzerland? We work in Luxembourg, and the from these providers is really scarce, to say the least. So how is it in Switzerland? Is it better? Is it really advanced? My question is, was it pretty easy to integrate your data of everything in the flow?
Hello? I can answer.
Thanks a lot for the question, because this allows me to highlight again what is so special about this project. Our data is not better than yours. So we had to work with incomplete 2-dimensional data. And what we wanted to show is that even if you've got incomplete data, we can generate, by using intelligent hypotheses, something which really gives a huge impact on your knowledge about underground objects. So what I would like to say is, data, we could do the same. Thank you.
So actually you just have to use your 2D layers, a bit of artificial intelligence, then transform it in 3D, then you visualize it, and you get the same.
A question in the room? No? Marion, maybe you can ask a question? Be prepared. Marion?
Sorry, I was on mute. So yes, some questions that we would have for you, Mr. It would be like maybe a question like in Switzerland or in the Geneva district. Are there any legal requirements in order to improve the quality of geospatial information of subsurface or underground utilities and assets?
Yes, we actually have, and we anticipated it by adding an extra category in our ontology that we call PLR for public law restrictions. And actually, we had to model extra models, extra objects that are purely not visible objects, but they have to be inside our spaces to be considered, and they fully integrate the low aspects of our zones considered.
Okay.
I think the
Thank you.
question was more or less if there are legal requirements which oblige providers to supply 3D data. Was it your question? So if it's your question, I can say that there is so far no legal requirement to do so. And even if the services provider in the Geneva canton ask for 3-dimensional data, well, it will cover only a very small percentage of the territory. So I think this approach which we presented here is quite useful still.
Okay.
Thank you.
Thank you.
So if there is no more question, thank you very much, Mr. Adwan.
Thank you.
Congratulations for this demonstration.
Thanks.
I propose to switch to the next presentation. Is Didier Soto online? The next presentation should be carried out by Didier Soto. Are you online, Didier? No? Sorry. Okay. So I propose to switch to the next presentation because I can see that Evandro Alfieri is online. So, hello Evandro, how are you?
Hi, good morning, bonjour.
Hi.
Yeah, good,
Morning,
good. What
bonjour.
about you? Sorry
You-
for the previous interruption.
I know you were very excited to come to Lyon to present your job, but you cannot come because of COVID. So it's so sad you cannot come. I'll let you introduce yourself, but before I want to thank you for the job you have carried out in the IFC-RAIL project in the technical services to provide the new standards of IFC 4.3 and to start the implementation program with software vendors inside the IFC-RAIL project. So thank you once again for your job, and I propose that you introduce yourself and that you present your presentation dedicated to the computational specification of IFC infra models, and you can understand that it is a presentation dedicated to the quality of structured information. That is a common issue for GIS and BIM data sources. So the link between the previous presentation and your presentation, it's the quality of the information managed in several data sources. So I give you the mic, Evandro.
Yeah, thank you very much, Vincent. And once again, it's really a pity I couldn't be there. I really wanted to meet you once again after the great experience of IFC Rail. I'm sure there will be another time in better conditions. So let me start sharing the screen because my introduction is included. Just tell me if you see my presentation.
Evandro, please wait a minute. We have a technical issue. We can
Yeah,
see
no
you
problem.
and we cannot see your screen. So I prepare your presentation on the PC here. If it is not possible for you to share it by yourself.
I'm sharing at the moment. Just tell me if you see it or not.
Yes, just try to show your screen on. It is okay or not? Yes, you can show your screen, but you cannot see you. But it's more important you can show your screen. So let's go.
Do you want me to turn off the webcam? Maybe, I don't know if this can help.
You can start. We can see your screen, Evandro.
Okay, so I'm starting the presentation. Just tell me which, because I have multiple screen, which one do you see? The one in full screen or the one with the notes?
So what I propose, Evandro, because we cannot see your screen, I propose to switch your slide by myself in the room, and you give me the go to switch to the next slide.
Yeah, sure.
It's okay? So go ahead, please, Evandro.
I don't see your screen. Okay, let me listen. Okay, now I see it. Okay, so sorry for the technical problem once again. Welcome to this session titled Computational Specification of IFC Inframodals. Once again, you can go to the next slide. Yeah, sorry, it will be tedious in this way. I have to say next, but can you maybe go in full screen so we don't have to scroll the video?
Okay, good.
Okay. So my name is Andro Alfieri. I work in the fields of information management here in Italy at Engisys. And as Vincent mentioned, in the last 4 years, I've been involved in the overall effort of Building Smart to develop the latest IFC standard for infrastructure, covering all the various domains of infrastructure with many stakeholders. And I would say that I'm deeply involved in the challenge of, as Vincent said, the quality of data, meaning collecting requirements and making sure that those requirements make their way into a formal specification, that this specification is delivered to something that has to understand it and to translate into answers and then deliver back the results and the response to these initial needs. So I'm quite sure you're familiar with this process, and probably you agree it's not a very smooth process, or at least subject to improvement. So you can go next slide, please. So this improvement in the process and data quality is the subject of today's presentation. I'm going to break it down into three steps. First, a bit of context about the information management process in the construction industry. Then I will show you a couple of application of the methodologies and tools that we've been using in the last year to ensure the quality of the models. And then I'm going to close with some opportunities that I think we should all embrace regarding this topic of data quality and so on. So yes, the context right away is that, as you know, very often the process is involving a client and supplier exchanging information. Usually there is a client providing a specification to a supplier, and the supplier giving back the model. As you see here, not always the specification is understood by the supplier, or even if it's understood, sometimes when the supplier submit the model back, the client is not really happy, it's not really satisfied because it's not sure that what the model contains is really what they needed in the first place. So you see from the 3 icons below that the results is usually models that are not what expected, not up to quality, a long and tedious validation process that can take a long time, and of course some contractual problems that usually raise out of it. You can go next. Because that's why you see Regula logo in that, because Regula is the answer to all of these problems, at least what we are developing at the moment. Regula is a tool that helps helps the clients to specify its requirement in a formal way and submit these requirements, this specification to the supplier that can build the model and check the model against the very same specification that was made by the client. Then, of course, it can submit the model to the client, which has the same capability of validating models. You can go next. So, how does this work in practice? As I said, Regula is a web-based platform. So you first create your specification starting from a catalog of rules, which you can pick. These rules are built and written in a natural language. I'll get back to this concept. And these rules are enriched with examples and metadata so that the user and the client has a full control over them and can understand them. So it can build a specification. The second step is, of course, the specification can be attached to contract or simply passed over to the supplier. And then, as you saw before, either the supplier is building a model and check himself the model before submitting to the client, or and the same, of course, can do the client when receives the model back. So the result is a validation report showing all the different rules and all the different steps, if they are fulfilled or not, what has failed, what has passed, and all the elements that's supposed to be adjusted. You can go next.
We can see you now on the screen, Evandro. It's good news.
Oh, okay. Can we try again? Because at this very point, I would have a video, so I don't know how you can. The video is embedded in the presentation. So can we try again?
I asked the technician if it's possible for Evandro to share his screen or not, because he has a video.
Yeah, this very slide is a video. Otherwise,
okay. But I have only a PDF, so I cannot show you video. So
I don't know.
Can you share your screen? Do you have the?
Yeah, sure.
Yes.
Sure.
The technician has your video also, so the technicians will show your video on the screen in the room.
Okay, so let me stop sharing. Yeah, the video is embedded in the presentation, so if you have the presentation, you can play the video. Anyway, this is a video. It's a quick overview of the platform. So what I just presented you, how it's structured with all these modules where you can specify, validate, and you have the rules catalog, where you can pick the rules from. So it's a really short video, a couple of minutes, just to give you an overview, an idea of the platform, so that I can go directly into the examples. Otherwise, it will be a bit tricky to understand.
Okay, you can play the video.
Hi everyone, and welcome to this session titled Computational Specification of IFC Infra Models. My name is Evandro. I work in the field of information management here at Engisys in Italy. And for the last 4 years, I've been also involved in the Building Smart International
So wait a minute.
So on a daily basis, I deal with everyone, and welcome to this session titled Computational Specification
Oh, no,
of
this is not the
IFC
video, sorry.
Infra Models.
This is
My
the
name is
entire
Evandro.
recording of
I
the
work in the field
presentation.
of information management here at Engisys in Italy, and for the last 4 years.
So wait a minute, Evandro. We have a technical issue.
Yeah, not a problem, not a problem. No, the video is not in these. Okay,
Okay.
the portion of it's not in these video. This was a backup video. Sorry.
Ev- ev- yes, Abe. Evandro, you recorded your presentation before the session, and can we show the
Yeah,
slides
sorry.
with
The
the voice?
video is not in it. The video is not in it.
Ah, okay, okay.
It's not in the previous one. This one was like a backup sent in November maybe. Yeah. So if I share the screen, you don't see my screen, right?
Try again to share your screen, please.
Do you see the presentation?
I can see it.
Thank you, Marianne.
We just need a few seconds to make these movies online. In fact, it's quite more question of streaming than. So thank you for your patience.
Yeah, no problem.
It is arriving. It is arriving. See your screen, but it is very little on the screen.
I can go in presentation mode and then the video should start in full screen. Just tell me if you see the presentation.
Hi everyone, and welcome to this session titled Computational Specification of IFC Infra Models. My name is Evandro. I work in the field of information management.
Do you think you are able to show the video, or we go on with the rest of the presentation?
Okay, so
it's almost ready, Evandro. Sorry.
yeah, no problem, no problem. Just tell me when you see my screen.
It's okay, Evandro. We can see your screen now in the room. You can start
Okay.
the video.
So we'll start the video. There is audio in it, so let me know if you don't have the audio. I will simply talk on top of the video. Okay.
Okay.
There's supposed to be some sounds. Just let me know if you don't hear it.
Now let's look at the platform itself. As soon as you sign in on the platform, you will be redirected to the homepage, which presents some shortcuts. A shortcut to the Getting Started path that helps users to test some files. A shortcut to the Rules catalog, to the Specify section, and the Validate section. The Rules catalog contains all the rules that are present in Regula that can be filtered by name, description, code, category, or IC version. Each rule has a code, a description, a title, and some details. These rules can be selected and used to create a specification in the My Specifications tab. You can either create a specification from scratch or use one of the templates. Whenever somebody shares the specification with you, you can save it in the Shared with Me tab. And all these specifications can be used to validate new models. Validation happens through the My Validations tab, where you can select a specification, select an IFC model, and validate the model through the Validate button. Of course, keep in mind that to process the validation, you need to have uploaded the IFC file and also the dataset files that goes with the rules inside the specification. And you can do that through the My Files tab. This ends the review, the overview of the platform. Should you have any question, please feel free to contact us at info@.
Okay, so you still see my screen?
Yes, we can, Evandro. Go on.
Okay, so this was just an overview of the platform, showing you the different parts of it. So the validate part and the specification part, plus the catalog. So you understood that at the core of Regula, there is a platform of rules available to everyone. And these rules are covering different topics, different areas, such as properties. There are rules for properties, rule for alignment, rule for checking assemblies and systems and groups, the model breakdown, and many more. So this catalog is growing on a weekly basis, I would say, and is supporting all the version of IFC, so IFC 2x3, IFC 4, and the latest IFC 4.3. Where Regula is placed inside this information management lifecycle that many of you are familiar with, I would say in different moments of the lifecycle, you can find Regula really useful. For sure, at the start of the delivery phase, to define the exchange information requirement in a formal and computer interpretable way. Of course, also at the end of the delivery phase, to validate BIM models against those requirements, and in a delicate phase also, where you have to manage the transition, the handover from the project phase into the maintenance phase. So the project information model into the asset information model. I have an example on this that I brought you today. And everything in between, basically. So everything in between the start and the end of the delivery phase, where you have the need to specify information and validate information. I would say Regula is definitely here to help. Today I brought you 3 examples, 3 applications of the use of Regula. The first is the definition of the exchange information requirement and the subsequent validation of it. The second is a use case where there was an handover from a project model project information model to the model that needs to support the asset maintenance of a railway infrastructure. And speaking of railway, the last example is something coming right away from the IFC Rail project, where there was a need to check one railway track, and the need was to check that the alignment of the native model built with a Bentley application, if I remember well, was consistent with the IFC model. So the first part, definition of employee information requirement. You see here that I took four rules from Regula. I wanted to check that the mandatory property sets are included in the model. I wanted to check the properties that are included in the property set are there. So not only the property sets, but also the properties inside those property sets are the one that I've requested. I wanted to check that the values of those properties are not null, neither empty. And last but not least, I wanted to check that the values of those properties belong to a predefined list of values. So you see here, I took as an example a model of a building where I had a door. You see here, the door name M single flash, da da da. And you see here a P-set door common with the three properties, and I intentionally changed this fire rating in order to generate an error, a mistake, using a random value like 19. So here is the specification in Regula. You see here there is a set of rules. You see the specification name, description, creation date, and then the four rules that I just presented to you. And in this case, you see here that the rule property values belong to a list of values, last one, is fed with some parameters like these property set and property name associated to this entity. And for the fire rating, I provided also a list of values separated with a comma like 10, 15, 12, 30. Okay, so everything that doesn't fall within these values is considered an error. Okay, so this is the wrapper, how it looks like. So you see that 3 rules out of 4 are passed. Okay, so this is the result of the validation. You see that 3 rules like property values are non-null, mandatory property sets are in model, and mandatory properties are included in property sets are all passed. It's a 100% success. But when it comes to property values belong to a list of value, we have one error highlighted here. Let me zoom in. So the error is telling you that there is an entity with this ID and this GRU ID and this name, M single flash, if you remember the name of the door. It's an IFC door. It's telling you that it's an IFC door. And the message is saying that it has a property fire rating, which is correct. In the property set, P-set door common, which is correct. But the value is 19, which is not included in the list of the requested values. So these are automatic generated messages that are supposed to help fixing the models or identifying the mistake. So that's it about the first example. Let me dive into the second one, which is the handover of a project information model to the assets management. So I need to make a bit of context here. You know that for asset management purpose, at least in railway and in Italy, but I'm sure it's a common pattern, you don't need to maintain every single element, every single object that has been modeled for the design and the construction phase. Most of the time you need to make group of things because those represent assets, and the maintenance is done on top of those assets. So not really on really detailed element, but more a collection of elements. So there is a need to group objects into assets and create system of systems. Like in rail and road, it's a common pattern. And then you need to maintain those groups, those assets. So sometimes there are elements in the model that are requested for asset management purpose. And in the model, you might have other elements that are there for, I don't know, construction purpose or design purpose, but you don't really need to feed them into the asset management system. So it's really kind of a selection of objects that needs to go forward to maintenance. So in this case, you have the asset number A, which is made by asset X and B, but only B is required for maintenance. So it's all about grouping things and leaving things outside. So in this case, the rules made of Regular were to make sure that the mandatory objects are present in the groups or system that are supposed to be maintained. So in the case of A, I wanted to be sure that at least B is included. If there is also another element, it's not a problem. Probably it's there because the model is a bigger model, but I'm interested only in making sure that A contains B. The same, I want to make sure that B is grouping at least C and D. Okay, I don't care if it's grouping other things. Okay, so you get the concept. The first rule is checking that at least the objects that I need to maintain are grouped into the group that I'm requesting. And the second rule is more strict because it's asking that the groups are made exactly by the requested object. So no more and no less. So just the one that I need. Okay. This is of course a more demanding specification. So you see that in the case of these breakdown structure on the right, the first rule will be a pass because all the elements are there. But the second rule will generate a fail because I will have also some other elements into my groups that I haven't requested. So this was how the specification is look like. So you see here a list of group. For example, let me read it, the first line. There is the first group of this type. I want it to contain minimum 0 and maximum 2 objects of this type, IFC asset impianto radiomobile. So in this case, if you read line by line, you get a concept of grouping, like IFC system of this type contains minimum 1, maximum 1. It means exactly one IFC built element of type cable. So you get the concept. We provide all these requirements in a CSV format, so the rules knows where to go to check the IFC model. And this is the results. As you see, the first rule is a pass, is a full success, but the second rule has an issue because it found one element with this ID and this GoID, with this name, which is an IFC asset, which is grouping one IFC system of this type that is not requested. So you get the concept. Second, that's it about the second example. Let me quickly wrap up because I think that due to some technical issues, we're probably out of time. This one is coming directly from the IFC RAID project, as you can see from the logo of the Italian infrastructure manager companies and ACA Software, which is in this case the provider of the IFC model. In this case, we wanted to check, we had a 16 or 50 kilometers line of alignment made of the different components, so horizontal and vertical layout of the alignment. And we wanted to make sure that the native file generated from the software vendors, in this case is ACA, is equivalent to the IFC file generated by the same software vendor. So it's all about consistency of native model and IFC model, which is also a really important use case for our stakeholder. So in this case, you see here we made a specification made of 6 rules. We wanted to check that it was a single project in it, and we wanted to check that the alignment is made according to a certain criteria. For example, I was expecting one alignment, one and only. I was expecting one horizontal layout and one vertical layout, and no cant layout in this case. So in this case, there was no super elevation. So I wanted to check that it was 0 cant layout in the model. And also I wanted to check the segments of these alignments. So in this case, I highlighted the horizontal segments. As you can see here, I wanted to check all the tolerances of the segments. So each and every segment constituting the alignment, and then the starting direction, the radius of curvature, the length of the segment. And on these values, the stakeholders define some tolerances that needs to be respected. For example, the tolerance for the starting point or the tolerance for the direction of the tangent, some very detailed requirements that of course it's very tedious to check manually. So in this case, the tool is able to interpret this requirement and check the model against it. As you can see here, in this case, everyone was a success, but the horizontal segments and the vertical segments has some problem in the tolerance. So let me wrap up. These were the 3 examples, just to give you an idea of what Regula is capable of doing. Let me wrap up with the opportunities that I see for Regula and use of Regula in these use cases. It's of course a formal specification, a transparent one that is written in a language that both humans and machines can understand. And it's based on an open standard, such as IFC. So all these means that this can be used in contracts, because again, it can be understood by humans, it can be printed out or passed over, but it's written in natural language, so there is no need to interpret it. And can be reused across multiple projects, because the rules are there, are public, and they are built on the IFC standard, so in a language that I'm expecting to be open and standard and be there and get reused in another project. As you understand, this is a process that it's not simply tied to the modeling activity itself. It's more about changing or making more robust and increase the quality of the exchange process, of the overall exchange process. So not only the model, but the entire process has to be managed in a digital way, in a computer interpretable way. And of course, these require the help and the support of the entire community. So the client and supplier all together work for a greater good and a greater results of quality in their BIM model. My last slide is really, let's say, a message to you to stop by at regula.io and give it a try yourself to the tool. You can subscribe and play with the tool. It's free forever. And if you think about contributing to the rules catalog or wanted to know more, just send us an email at info@regula.io. I also leave my contacts and the contacts of my colleague here, so you can have them in the presentation. And I think that concludes my presentation. Thank you very much. I'm open to questions now.
Thank you very much, Evandro. What we just presented make very sense for the implementation of the standard based on the use cases that I presented yesterday in the railway session. In the need to implement some new use of digital information in our activities, and we need to have tools to be able to require some information and to deliver some information based on rules, based on requirements. So what you presented make very sense about this implementation process for next years. Marion, do you have any question on the BRELA?
No questions in BRELA, but yeah, do you have some questions from the live audience?
Any question in the room? It's a very specific point that has been presented, but I recommend to show the presentation once again in a bigger screen, but because it's very crucial what just presented. No question in the room. Maybe you have a question, Marion?
Yeah, first of all, thank you, Evandro, for a very enlightening presentation, and also congratulations for the development of, well, a solution that very clearly has really great potential. My question is actually more of the point of view of like my position as I'm at the Finnish Transport Infrastructure Agency, and we plan to implement IFC 4.3 during this year already. Would you have any recommendations or ideas about what, from your viewpoint, would be the best way to incorporate the use of Regula into contracts? You mentioned that in your presentation.
Yeah, sure. By the way, can you hear me?
Yes.
Okay. So thanks for the question, of course. First of all, let me say I'm really helped to see that stakeholders are pushing for the adoption of IFC 4.3 in general, because I think rather than using Regula, even pushing for IFC 4.3 and start asking it, it's really a big move and a big push to influence the market. But other than that, you saw that Regula is working with other previous version. So in general, I would say that in Regula, we have multiple ways that you can share a specification with the customer. Actually, thanks to the feedback of the early users, we built a function where a specification can be shared directly in Regula to another Regula user. And we are also, we built also a functionality for the other user to check its own model against the received specification. So the first suggestion would be start using Regula and build your specification and see if you can use Regula itself to manage this process, because again, the idea is to keep this process digital. But of course, you can always print it out because it's written in natural language. So if you keep it in Regula, the platform has the potential to understand the model, understand the rules, and act and execute those rules on the model directly. But if you wish to print them out and attach it to contract, that's perfectly fine. Actually, that's good, because those rules are not written in code, but are written in natural language. So it makes sense also to print them out and attach it into contracts.
Hey, thank you, Evandro.
Thank you so much. Thank you, and thank you, Marion, for the questions. I propose the next presentation that is presented by Boutin from SNCF. I need some help to close the previous presentation. Please give me. I can. So I let you to introduce yourself. You'll start your presentation.
Okay, thank you. Thank you, Vincent. So, hello everyone. I'm Judica Boutin. I'm from SNCF Réseau. It's a pleasure to present you the result of one experimentation around using BIM and GIS technology to reach specific objective on railway maintenance. That's something specific. I will. This presentation is in two parts. I will present the business part of this work, and I have Content Market, who is online, cannot attend physically, and he will show its video on the technical part of this presentation. And by the end, for question answer, he can also support the presentation. What is just about just a few words about SNCF Réseau. SNCF Réseau manage the French railway network. With just to highlight the kind of activities of SNCF Réseau is to manage 30,000 of kilometers line in France, and it's about 1,600 work sites in France with 15 passenger train per day, So that means that behind the SNCF activities, the maintenance is play an important role to keep this capability always operational. So that is a key issue on that. We need to keep the railway always operational. So the experimentation on the using BIM is to how BIM can help this and how we can use BIM for that. So just a few words of BIM deployment in SNCF before start to the core of the presentation. We have a deployment of BIM in 3 phases at SNCF. The first phase is about development of the skills. Skills mean manage the maturity of people, manage maturity of tools, and manage technological integration of the different tools that can be used to have an integrated system that works. And the second phase is about industrialization. That means BIM mandate. That means generalizations of BIM tools. And that means using information coming from BIM for different process where the objective is make the railway function. So by the end, the objective is to reach step by step by end-to-end digitalization of the railway system by overall. So that is a global railway. And to come back to the experimentation contest, we use BIM on 30 kilometers of length in south of Paris. And the idea is to check how the BIM and the BIM philosophy can help to do that. And the starting point for this is to use existing data. Existing data is something classical about different kind of CAO information from the different sources, but it's also massive data coming from the LIDAR data, point cloud, and massive data coming from the line side database, internal database, geolocated database. So the first step is to have to manage all that to create. Not that. To create, first of all, the track, like 3D, in 3D, that's a front asset on the railway, like to the first step and the first layer create. So the main issue here is how to use rail length, many kilometers rail, and to manage really the count, to manage the 3D aspect on that. That is to be really usable, using information starting from 2D information, just point cloud, in order to be able to industrialize something and to do massively this task, because you imagine that if you start digitalization in always railway system, we need massive algorithm, we need something really to be able to use in context of massive data. So that is some issue here. And to come back to the maintenance aspect, what we need to maintain and how can we create digital model for that. The idea is first of all to identify how, if we start, the starting point is design, how the design can take into account maintenance issue to have the right digital model. So we start to analyze the asset we need to manage. For that, the maintenance issue on track, for example, is really about track defect. We need to identify track defect, and there are many databases behind that. We need to define geometry, because at the beginning of the railway system designing, the design is made by geometric tolerances. That is a track, because it's a requirement to keep the train on the track. So this requirement is used to make some monitoring of the system right now. That's something real. And we need to have connection with the associated database. And we had also to manage turnout, because turnout in the railway system is something really critical. We are monitoring that really precisely. And by the end, you have some how to represent those information in digital BIM. That means that if you have some kilometer of track, you need also to manage how, at which moment you have some changement of the for example, your digital model need to be able to have this representation in order to associate database on that. And something more simple is about preparation of punctual defect. That is, for example, track defect is just what I see the next slide there, for example. We need to point out that something you cannot see visually by, you imagine the guys who is need to find the maintenance to check where the real defect is something 1 millimeter, but so it's not possible. We have some monitoring tools to do that, and to help the people who need to go and to check and monitor that, or to make something on that, we need to have comprehensive. The idea is to make BIM able to do that. And we have this phase is about representation of this default on using dedicated representation. That is subjective, but the one kind of representation that helps to represent this digital model in the comprehensive 3D environment. So the end of this is that we create by is not a process from design, it's just something created from the massive data connecting multi-source data, and this connected these objects in the digital model. And using different techniques of which Quentin will present next, we test many tools on this process to evaluate the capability of different tools, different capability to bring this information in this context 3D model. By the end, you have some people who need to maintain the track. The idea is that he can have this 3D model and click on it and have database coming from directly the database maintenance to have in the field, for example, that this information in to make the right action for maintenance. And by the end, we have integration of all this model around the 30 kilometers, and we make some tests to evaluate how this model, because the idea is first of all to create that, connect that to the real database that is used for plane maintenance, and by the end the idea is to bring these information to the right people who need to use that. So to do that, we try to test many technology on that, how the combination of multi-technology, GIS and CAD world can work, and what is the issue on that. Can we say that everything is okay for that, or is some issue on that? I think Quentin will come back on the test we do on that, on this in this idea. But for the business side, what is, I mean, maybe the grail for operator, which is SNCF, for example, on this maintenance, to say we have a digital mock-up. This kind of thing may come from the design. That means that the people who design the track, with the information he has, so the different kind of track he have, you can see it visually. He prepared the model by the design phases to have really the different heterogeneity of the track. You have some sleepers different, we have some different kind, which is massively done by the machine, and where is the changement of that is not the same way you have to maintain them. So for the people who maintain that, it's important for the design phases to have this information to be able to connect some other source on that. If the guys of design don't have this information, is something more difficult to do later on. So can anticipate that. That is something really nice. And if you have some kind of model, what you see in the screen is we have some different filters of that. And what you see, for example, in red, that means that the next maintenance operation will be done next week. So you imagine that if this information we can be able to put in the, for the people who plan maintenance, he will avoid to go to the field to show exactly what he needs to do. And he can play for this at the office exactly where where he want to go plan his maintenance. Instead of go overall the 13 kilometers to show where to do the work or to fix exactly what is the issue on the track, he will just use his database where all this information is available and put it in BIM data and have visual view on that and focus really on what he want to do and what is the right moment for which is the action to do next week, for next month, and in the planification way. So that we expected that we can be able to make this application available on a more real site, because we do it with the maintenance guys, but actually the database is not continuously connected to digital code. We need to test and to find how to make that, but also to have this kind of way to take into account the maintenance operation from the design side. If you have the track model, we hope that this kind of representation of track is taken into account in order to facilitate the connection of the information coming from the database, which is globally GIS database. That is the immediate objective. So now I propose you to, for technical aspect, we try and we test many things. I left maybe the video of Quentin who will present you the different steps we do to have this result. So if we can have the video, thank you.
Hi JDK, many thanks for your presentation. I'm Quentin, a BIM and GIS consultant subcontracted by SNCF Réseau. In this chapter, we will talk more deeply about software and data flow information. For the first experimentation about maintenance model authoring, we used Dynamo visual programming to link external alphanumeric data to 3D solid coming from corridor in Autodesk Civil 3D. This workflow was admissible for rail or ballast areas, but we discovered some deficiencies about slippers implementation. We had objects, massive rehearsal, and maybe it will be smarter in the future to use a GIS approach with 3D symbology. In fact, whatever could be the physical representation of a slipper, timber, concrete, or by-block slipper, it would be preferable to use only points and change stylization on the fly. Moreover, to use Dynamo, we had to use IT robots programmed to extract and so duplicate information from internal data lakes. Still, with a GIS approach, we can expect to complete a better job in the future by a direct connection on urbanized data with our new Trimble Quadri and Connect command data environment. Connectors are the key to the success. The project was completed in 2 phases. Phase A, experimentation on 1 kilometer length. The IFC export is about 184 megabytes without the terrain. For the phase B, it was the full maintenance area described previously by JDKL. For 30 kilometers, we have 2.5 gigabytes IFC still without the terrain. The last one was too big to be created in only one part, so we had to split it in 3 areas. As you can see, with the files WAF, BIM models are not the best solution to support the full tracks managed by an infrastructure owner such as SNCF. Initial EFC file for 30 kilometers maintenance area was so important that some SaaS platforms were not able to read it. Here, for example, the Mesoteam command data environment from Prozis. It required to split in several small length areas to open it on the cloud, still without the existing ground. So that was not possible to have our terrain with IFC due to an important linear and numerous tracked internals. we decided to start experimentation about CityGML format. CityGML is an open standard issued by OGC. About it, please look about their new logo. We had several levels of detail representation and are very different that we can have for BIM model and new ISO 19650 definition. To start writing CityGML, we reused former investigation about FME middleware and former scripting. With VRMS distributor in France, we were able to recreate geometry coming from GIS data tables by fixing a solid tree construction upstream. Thanks again to this team to inspire us and complete our first step alone with FME Workbench. Moreover, to identify the main useful transformers allowing to write or transform CityGML, we had access to several samples coming from Safe Software. Do not forget that this technology is the only way to bring back files to AutoCAD, to Autodesk Map3D, InfraWorks, or Esri ArcGIS ecosystem. The first step was to write CityGML directly from a native model authoring file format. We discovered just how to complete scripting, and we didn't try to optimize the features in correct classes. We just used generic city object. We had a surprise for the 22 GB weight due to slippers representation. For the future, we will for sure investigate 3D symbology for slippers. Unfortunately, very few viewers can read directly CityGML, especially in 3D. Some of them can only open in 2D, such as QGIS. CityGML is a complex data model and requires very large files. Each of them can be directly edited by a simple notepad. About geometry, CityGML uses only boundary representation, named BREP, and cannot use the CSG or sweep path representation. The second step was to write CityGML with simple feature, no longer as a generic city object. Randomly, we choose what sounds the most similar object without integrate the potential links between several CityGML features or parts. After all, when you are discovering CityGML classification with an ETL tool, all features are listed by alphanumeric order. A transformer dedicated to appearance allows us to keep different colors, and we discovered that FBIM software from CSTB can load several GML files and aggregate it without the requirement to have all placed in the same file. 55 features are standardized in CityGML format. Each of it has its own requirement related to level of detail 1 to 4, following also the kind of geometry, solid, multi-surface, multi-curves, and so on, and feature roles. It is more complex than we thought to find the correct combination and succeed to write CityGML files. After completing the first script dedicated to simple features, we started our investigation about advanced design, especially about bridge and tunnels. The process is still ongoing. The job is very different due to the assembly of features for a bridge. You can see the UML diagram on the right, and you will have to manage bridge construction element, bridge furnitures, bridge parts, bridge installation, and bridge rooms. There are numerous sub-features. Of course, you will have also a similar definition for tunnels. Don't forget, whatever you are working for bridge or tunnels, that the structure is based on a road, so a transportation part, also linked to the terrain. Semantic and topology representation must be taken in consideration. Until now, we just worked about translation of native files to to CTGML format. The next goal is to be able to convert directly IFC files to CTGML. On the screen, we already have experiences to write it with an ETL tool, but we still need to investigate how to transcribe IFC places in BREP and keep alphanumeric data with attribute mapping. Cherry on the cake, FME Workbench has transformers allowing to bring back to the geographic context some design produced by non-linear tools such as Autodesk Revit. We didn't start again to have a look about it, but it will be a future challenge. So, once again, thank you for your presence and for looking this movie. Whatever where you are coming, please enjoy your trip in Lyon in January 2022. Thanks.
Okay, thank you. So as you saw, we have this job. If you have some question about the business phase, I can ask you. I don't know if Quentin with us. We cannot. I don't know if you can connect with Quentin to answer directly. If, normally it's online for tech. But in general, just to summarize what we do here is have some. We have some issue managing massive data. If you have maintenance issue, it's not just project scale, it's something bigger. You have some people who need to manage larger scale. And the idea is if we don't have digital twin available, we need to deal with existing data to make something. The first step is to create data, to share it, and to make many manipulations to have comprehensive to working on BIM environment. So the idea is to test many and also to evaluate the gap between what we are able to do now and the step to go further and what we need to do to improve the process and to prove the tool who are able to help us to make this kind of issue. So if you have any question, thank you.
Thank you very much, Judicael. It's very impressive what you have shown just before. Once more, the SNCF strategy, vision, and what you it's very inspiring for us to go ahead in the deployment of digitization of the activities. So it's very impressive. Thank you. Marion, do you have any question on the BRELA, or are there any questions in the room?
No questions in BRELA yet, anyways.
There are much more people in the room than before, so if you have any question, yes, then.
Thank you, Judicael, for your very nice presentation. So, as far as I can understand, your strategy now is not to focus on just on BIM, but to focus on GIS for operating and maintenance support. So the thing is, do you have right now specification for BIM model that company will produce for you in different projects to allow you to implement your tools easier or in a more efficient way into your database? Do you already have something that we have to do or something that we surely not have to do to allow you to implement it quickly and safely?
Yeah, very good question. I think we are trying to make something in the contest. We need to produce, but we'll also need to develop something to integrate. So it's something we need to this step by step. And right now we don't have clear specification on maintenance phases, but it's something we are working on. And what we have done yet is always to say, okay, at design phases and what is the work in IFC project to specify a PSET. That is, we know that at design phases, this information is always available. Typically, if you have a design phases and you have some track, you know exactly what is the monitoring you need to put in place to monitor this kind of track you implement. So this information is always available in B model. So you can always come in for the designer specification you have. You can always put this in the model, and we cannot say that the specification process right now is always okay to manage all that in specific way, because people who are working on it is not BIM language speaking all the day. So it's something we will do progressively. But the kind of experimentation we present is put light on other aspect on that, geometrical aspect, or structure the BIM model to be able to connect information that is not possible. If we come back to the track we saw, we imagine that the designer put just one track for the beginning of the end of the line. You need to take your cutter and your model to say that, okay, this, and to create new object and to associate it. That is, you don't know which in the system can do that, because the system don't identify people who have this job to do. So you have a problem in your system. But if the designer take this into account, it can produce you directly a model that is shaped for you, that is shaped for maintenance, and that is the objective for this kind of experimentation also. To have directly by the maintainer what is the requirement for that, what is expected really. Is it the track, is it the slippers, or is it just in detail, or is it just which is point kilometers you want to change the game and to be able to connect object. If you don't have this connection, you cannot do that, or you need to put one layer of software on that to be able to do. So you make a layer of software, and cost, and performance also is not there. So I don't know if I answer the question, but everything is not clear. But we have this in is really concrete, in concrete way is the objective of this kind of experimentation, to make the requirement clear.
Any other questions?
Actually, we have one question from Umbrella now. If there's time for one more question.
Yes, go ahead, Marion.
Yes, I thought Mashiba has a question. Have you already investigated what the new alignment features from IFC 3 can help you for the integration of your data?
Not understand you. There is an echo.
Okay, should I try once more? The question was, have you already investigated the new alignment features from IFC 4?
Sorry, Marion,
can help the integration of linear data.
Marion, we cannot understand you. Sorry, there is an echo, so that we cannot understand you. So I propose that you send an email.
Once more?
No, it's a technical issue.
Is there no an echo?
Can you switch off your sound at home, Marion? Maybe it's...
So once more, the question, have you already investigated what the new alignment features from IFC 4.3 can help you for the integration of linear data?
Maybe, Quentin, you have understood the question. Maybe, Quentin, you can answer. Can you switch on the mic of Quentin, please? We cannot hear you, Quentin. we see you speak, but we cannot hear you. So we are a little bit late. I propose to go ahead, because for the people who join the, it's okay. Okay, go ahead, Quentin, if you have understood the question.
Can you hear me?
The question is on...
We use the CD3D and we don't have the opportunity to be on it.
It's not better, so sorry for everybody, we cannot... Okay, Judy, okay.
I can try to reformulate your question, Mario. Maybe if I'm okay, if it's okay, you tell us. Do you mean that if we check the IFC 4.3 specification, able to support what the experimentation we done? Is this the question? Mario? In this experimentation? Yeah, I think for this experimentation we only work on geometry, first of all, because many work on that first. And we don't really work on the specification. So the IFC 4.3, the main issue with that is information, is semantic. But so we don't use really IFC 4.3, we use existing tools. You can confirm, Quentin? Existing geometry, so since it's just geometry, we don't need AFC 4.3 for that, so it's...
Okay, once more, Judicael and Quentin, congratulations for what you have carried out. For the people who join late, we cannot start before the time because we cannot. The speaker number 2, but I joined the session umbrella. DJ, so we have his video. We can share the video for the presentation that propose Vinci Construction, which name is Infrastructure Operation Support Tool for Climate Risk towards a conversion between GIS and BIM. So I'll show their video live in the room and live in Breda. It's okay for you? Let's start.
Hello everyone. So today Didier Soto and myself are going to introduce you the challenges of BIM and GIS convergence for improving the set of existing tools dedicated to climate risk management, to climate resilience, and more generally to climate change adaptation. So firstly, some issues of BIM contributions versus GIS contributions. So the first part is the BIM. The BIM is focused on an understanding of the infrastructure, the building, the railways, and so on. So all the features of the given infrastructure. And the GIS is more focused on an understanding of the infrastructure surrounding areas. So for example, the living and working areas, the connected services, the connected infrastructures to our given infrastructures, and all the environmental, geographical data. So for example, the weather and the climate context around the infrastructure. And the GIS allows to aggregate all these different data coming from environment, coming from networks, coming from infrastructure operations, and so on. So why going through a GIS and BIM convergence? So a convergence between those two environments. So because this combination allows to integrate the infrastructure within its own environment, its own geographical context, with its specific features. So more precisely, it allows to understanding the influence of surrounding areas on the infrastructures, so which damages could occur, the malfunctions, the premature aging processes, for example. It allows also to assess the conformity of the infrastructure dimensioning by putting it within its context, its environmental and geographical context. It allows us also to assess the impact of infrastructure disruptions on the global territory, the surrounding areas. And it also allows to include environmental changes for a better and a more relevant risk management. So in this context of BIM and GIS convergence, we developed a first theoretical approach dedicated to climate-related damages if an hazard occurs. So this is based on what we call the functional resilience modeling. So meaning globally the capacity to a urban, a rural area composed of many infrastructures to absorb a shock and to get back after that to a normal functioning. So the inputs of the tools are, for example, the geographical related data, so usually coming from the GIS tool, the infrastructure related data coming from the BIM data or GIS tools, and the climate related data coming from usually coming from the GIS. And in terms of outputs, we are able to provide some functional diagrams and cascading effect assessments between territorial infrastructures, for example. So these outputs are going within the GIS tool. We're able to assess successive disruption scenarios, the costs, and repairing time associated to these damages scenarios. And we are also able to provide some general mappings of direct, of those indirect also impacts. And all this information, all these outputs are able to go into one of these two environments. So I will give you just a quick example with a short video of transportation network. But firstly, I will give you the steps of a given case study dedicated to this climate resilience, this climate change adaptation. So first, the idea was to go into a data visualization of the urban environment through, for example, aerial data. So here is a railway stations with all the railways infrastructure, as you can see. The second step is to get into a GIS model of the urban environment. So as you can see, we put on this aerial data the GIS associated model. The third step is to gather infrastructure data coming from the BIM model. And after that, there is, let's say, a lot of possibility by combining these two GIS and BIM data. For example, quantify the urban microclimates, mostly due to urban heat islands in a context of climate change. You are also able, by combining both GIS and BIM data, to assess cascading effects within an infrastructure and between infrastructures on a given territory, for example, when, let's say, a flood or heavy rain hazard occurs. And we will give you some examples, some precision on these two case studies. So here is the first presentation of the tool. So the video summarizes all the part of this project. So first, you have the possibility to select the infrastructure and its all related components. Secondly, you have the possibility, as you can see, to select the hazards, for example, the flood hazard, and in all its own features, so the speed of water, the water level, the intensity, and so on. And the combination of those two parts allow us to provide all disruptions scenarios, so meaning the successive damage components if an hazard occurs. And after that, you have the possibility to show all these results on the geographic information system, showing where are the damage components within the surrounding areas of the railway infrastructure, as you can see on the video. You have also the possibility to get further details of the damages processes by consulting the database behind the GIS for each component to really understand which are the processes behind an hazard when it occurs on your infrastructures and on your territory. Some first conclusions before giving the floor to my colleague. First, developing such tool within a GIS and BIM conversion context allow us to represent a representation of output data through open GIS softwares, for example, so by using QGIS, or by creating some web mapping, by using some web mapping application such as LISMAP. The possibility to use also open BIM softwares, for example, by using IFC formats. It allows us also to progressively use BIM models for managing climate risk and infrastructures adaptation to climate change, because today GIS is let's say one of the main tools used on these topics, and the convergence between GIS and BIM could greatly improve the analysis of vulnerability and resilience. And all this GIS and BIM convergence process is lastly in line with the objective of the current season of the National Mind project, with a dedicated working group defining all the axes of convergence between these two environments. So Didier, the floor is yours for presenting the second case study.
Thank you, Michael. We could go to the next slide, please. So, no, the previously.
Sorry.
So we will take the railway station of Paris Gare du Nord as a case study to illustrate how the convergence between GIS and BIM has been useful to model the future impacts of climate change. A new terminal is under construction, and the real estate promoter asked Resilience to assess the benefits of a landscaping project on the roof and the facade. Next, please. For this, we develop a 5-steps methodology, during which a workflow of GIS and BIM data and processes has been developed. We take input data from the French National Geographical Institute GIS database and the customer own data in an AutoCAD format we import into our GIS. We simplify the building geometry by smoothing the main facades. We make a 3D extrusion of the buildings to get a 3D model of the railway station planning project. Next, please. The second step was to calculate the potential cooling triggered by the landscaping project. We take from the BIM information and geometry data relative to the chosen vegetation. We calculate the radiation balance on the site for a typical sunny day, as well as the albedo properties for each vegetation category. Next, please. A specific meteorological scenario has been chosen with a maximum temperature of 31 degrees and a relative humidity of 60% to consider a particularly uncomfortable thermic ambience. Evapotranspiration has been calculated to estimate the latent fluxes brought by the vegetation according to its nature and height. by using the information taken in the beam of the railway, we estimate that the amount of released energy is the equivalent of 200 individual air cooling systems. Next, please. The third step is to develop a 3D mesh sizing of each building faces by taking information both from the beam and the GIS. We take into account building thermic properties following the construction materials and the shape and height of the buildings. The total amount of meshes exceed 2.9 billion with a specific resolution ranging from 0.1 to 2 meters in the main buildings. Please, next. The meteorological reference scenario is set on the fourth step according to the future expected climate of the railway station. Next. The fifth step is to model the wind circulation between and above buildings through a computer-free dynamic approach. Next, please. The results are post-processed in the GIS with an overlay of the air temperature values on the buildings and roads. It is now possible to estimate the loss of temperature induced by the landscaping project and to bring a cooling envelope near the roof and the facades to consider the 3D area where the temperature benefit can be felt. Next. So these several views can help consider the cooling envelope estimated to 0.5 degree. Next. 1 degree. Next. 1.5 degrees. Next. And the last 2 degrees. And next, please. So those videos can help understand the spatial dimension of our modeling approach with the first scenario of hot temperature around a maximal value of 31 degrees. We can precisely localize where the temperature benefit is the most important, mainly on the roof. The cooling envelope can also be precisely determined. Next. The second video deals with the very hot temperatures, 40 degree scenario. The evapotranspiration performance is less due to the drier and hotter thermic ambience, but the benefit can be localized on the roof. The width of the cooling envelope is also reduced. Next. So to conclude, our methodological approach through a dedicated use case contributes to promote the interest of the BIM GIS convergence, which appears to be a prerequisite of the resilience studies of infrastructures and territories led by Resilience. It helps characterizing the surrounding territories, understanding and qualifying the infrastructure, and exploring their interrelations. Our approach can help developing workflows to facilitate the integration of GIS and BIM data and highlight the needs to build capacities to develop a common culture of GIS and BIM uses among real estate promoters and infrastructure managers. The next steps will lead us to automatize workflows to optimize processes sequence instead of the successive steps we used in this study. Within the MIND working group, we aim to build and share common practices for designing and guiding interoperability of data, especially open data. We finally think that IA can be a good way to manage big data in terms of qualifying the resilience of building standards at each cycle life step of an infrastructure. Thank you very much for your attention.
Thank you.
Thank you to Vinci Construction and Resilience for the it's a test case, a use case that is very crucial for the, can you hear me? It is a use case that is quite in the need of the cities to no more, it's what we have learned this morning about the convergence between GIS and I think we learned the new way developed in our activity infrastructure. I think there are a challenge to data sources that are correct features to allow interoperability between different systems. I think it is the first point. The second point we see this morning to define a level of detail of the geometry each use that is by the different system that are used for the activity. The third point I think is that we need to define a level of need for each use case that's enabled to some information between two systems and to have on the fourth point we saw this thing, to have some tools to be able to define the context of the model we want cases and to check the quality of the model we need to have in the data for the infrastructure so that we can share information, reliable information between different asset owners. We can have trust in the information. We can have confidence in the information that. Thank you very much to all the speakers. Thank you to you for help in the animation of the session. Marion, can you hear me?
Yes, I can hear you.
Yes, we can hear you also. So thank you very much, Marion. Have a good day.
Thank you.
And
enjoy your time in Lyon.
And see you soon, hopefully.
Exactly.
Thank you to all. Thank you to all the attendees, and have a good. The session is closed.